Okay guys, so we are back with another material balance problem, and this time we have here problem 4.16 from 3rd edition of Elementary Principles of Chemical Processes by Richard Felder. Okay, so now let us check the problem. Two aqueous sulfuric acid solutions containing 20% by weight of H2SO4 with specific gravity of 1.139 and 60% by weight of H2SO4 with specific gravity of 1.498 are mixed to form a 4-molar solution with specific gravity of 1.213. So we are asked first to calculate the mass fraction of sulfuric acid in the product solution. Then, taking 100 kg of 20% feed solution as a basis, draw and label a flow chart of this process, labeling both masses and volumes. Calculate the feed ratio in liters of 20% solution per liters of 60% solution. And see what feed rate of the 60% solution in terms of liters per hour would be required to produce 1,250 kg per hour of the product. Okay, so una natin gagawin is to draw the flow chart. Okay, so now we have here our diagram, and we have a mixer right here and two streams for the two components na imimix natin, and our product will be right here. So isulat muna natin yung mga given natin, no? So first we have 20% of H2SO4 coming in. So let's say this is our mass 1. Okay, and we have here 20% of H2SO4 by weight. So that means we have 80% water right here. Okay, and then we have other streams. So let's label this as M2 and label this as M3. Well, itong mga variables natin ng M represents mass, but since we are also asked to show the volume, so we will label that as volume 1, and we have here volume 2, then we have volume 3 right here. And another given dito sa ating first stream is our specific gravity, which is 1.139. Okay, so yan ang given natin. Okay, now in our second stream, we have 60% by weight of H2SO4. So that means we have 60% H2SO4 here. So 40% water. And the specific gravity here is equal to 1.498. Our product stream is a 4-molar solution with a specific gravity of 1.213. Okay, so far, yan ang mga given values natin, no? And now, let us try to solve yung problem natin, no? So, let's start with the requirement for A, which is, ang kailangan nating makuha is yung mass fraction ng sulfuric acid sa ating product. So, what we need to find out is yung mass fraction ng ating H2SO4 sa ating product. And this is equal to the mass of H2SO4 in our product over the mass of product. Okay? Yung M3 yan ang ating product in here, no? So, now, what is our given para makuha natin to? We have the specific gravity, no, and the 4-molar solution. So, we know that 4-molar solution means 4 moles per liter of our solution, no? So, we have here 4 moles of H2SO4 over 1 liter of the solution. Okay, so that's the concentration right here. And now we will convert this mole into weight by using the molecular weight of H2SO4. And we know that in 1 mole of H2SO4, we have 98 grams of H2SO4, right? That's the molecular weight. And converting that into kilogram, because lahat ng ating given, if you'll remember dito sa ating basis here, it is expressed in kilogram. So it's better na gawin natin to in kilogram, no? So let us convert this 98 grams to kilograms. So we will have here 1,000 grams of H2SO4 to 1 kilogram of H2SO4. Okay, so now we have the weight of H2SO4. Now what we need on our denominator is the weight of the solution, and this is where we're going to use the specific gravity, no? So this could be expressed as kilogram per liter. So per 1 liter of our solution, we have 1.213 kilogram of the solution. Okay, and now we will cancel out those that we can cancel. So mole of H2SO4 will be cancelled out, liter of solution will be cancelled out, grams of H2SO4 will be cancelled out. So ang may iwan sa atin is yung kilogram of H2O4 over the kilogram of solution. So doing this, we have 4 times 98 divided by 1000 divided by 1.213. We will have 0.323 kilogram H2SO4 per kilogram of solution. Okay, so this is the mole fraction of H2SO4 in our product stream sa ating M3, no? So this is our answer for the first question. Okay, so now let's go to the second question. So what is the given right here? So we will use 100 kilogram of the 20% feed solution as a basis. So now as a basis, this M1 will be 100 kilogram. And we are asked to label the flowchart. We already did right here. And then we are asked to calculate the feed ratio, which is how many liters of 20% solution per liters of 60% solution. So basically our required here is the volume of the feed solution 1, which is 20%. This is the 20% solution, over volume 2, which is the 60% solution. So ito yung kailangan nating makuha dito, no? And we have that here labeled V1 and V2. Okay, so we have to take note that every percentage here is in terms of weight percentage, no? So that means our 20%. So that means our 20% H2SO4 here is actually 0.2 kilogram of H2SO4 per kilogram of solution. The same for our water. This 80% water here means 0.8 kilogram of water per kilogram of solution. So that's what it means. Okay? And so the same way here, this is 60% of H2SO4. This is 0.6 kilogram of H2SO4 over kilogram of solution. And for water, we have 0.4 kilogram of water per kilogram of solution. Okay, so yan ang ating mass fraction here. And in here, we have the mass fraction of H2SO4. We have here 0.323 kilogram of H2SO4 per kilogram of solution. Okay? And also, we could get the mole fraction of water because we will just need to subtract this number from 1. So, we will have here the mass fraction of water, which is 0.677 kilogram of water per kilogram of solution. Okay, so yan ang ating mga mass fraction sa lahat ng ating stream. So alam na natin yung mga values nila. Bago tayo magpatuloy sa ating discussion, we would like to ask for your support by subscribing sa ating YouTube channel. Please click on the notification bell para lagi kayong updated sa mga videos na ipopost namin. So first, let us do an overall material balance. And dalawang stream ang pumapasok, M1, M2, at lumalabas is M3, which is our product. And given ang ating M1, which is 100 kg. No? So we have here M1 plus M2 is equal to M3. And our M1 is equal to 100. So we have 100 plus M2 is equal to M3. And this will be our equation number 1. Okay? And now, in order to have another equation, we will do water balance. You can do H2SO4 balance. It's up to you. But for my case, I will do H2O balance. Okay? So, we will calculate how much water we have on the first stream, how much water we have on the second stream, and how much water we have on the third stream. So, first, we have 80% of water in M1. Okay? So, we have 80% of water per kilogram ng solution in M1. So our M1 is 100 kilogram of solution. Plus our M2, we have 40%, okay, of water. So we have 40% of water. And we do not know what is M2. And this is equal to our mass fraction in M3, which is 0.677 right here. So we will use that. 0.677 times M3. Okay, so in here, our unknown is M2 and M3. And using all this calculation right here, we know that the value will be in terms of kilogram, okay, of M2 and kilogram of M3. So we will not be worried about our units right here because everything is in kilogram, okay? So instead of writing that, I will just write it this way. 0.8 times 100 plus 0.4 times M2, which is equals to 0.677 times M3. Okay? So doing this calculation, we'll have 80 plus 0.4 M2. Okay, sorry, this is equal to 0.677 M3. And then now we will use equation number 1 right here. So we have M3 is equal to 100 plus M2. So we will substitute that here. Okay. So we have 80 plus 0.4 M2 is equal to 0.677. 100 plus M2. Okay. So we have now only one variable. We have M2 in here. So we could solve for that. So first we have distributive property here, no? So we'll do that. We have 80 plus 0.4 M2 is equal to 0.677 times 100. We have 67.7 plus 0.677 M2. Okay, now we have 80 minus 67.7. We have 12.3. And this is equal to 0.677 minus 0.4, 0.277 M2. So our M2 is equal to 12.3 divided by 0.277. So therefore our M2 is equal to 44.4 kilogram. Okay. Okay, now we can solve for M3 because If you remember, our equation 1 is 100 plus M2 is equal to M3. So our M3 is equal to 100 plus 44.4. Therefore, our M3 is equal to 144.4 kilogram. Okay, so may mga values na tayo ng M2 and M3. So we have M2 is equal to 44.4 kilogram. And our M3 is equal to 144.4 kilogram. Okay? So, meron na tayong M1 and M2. Pero ang kailangan natin makuha kasi is ito. Volume percentage, okay, ng 20% solution over the volume of 60% solution. So, kunin muna natin yung volume 1, which is volume ng 20% solution, no? So, we have the value of M1, okay? Our M1 is equal to 100 kilogram, okay? And this is the weight of the solution. So, we have 100 kilogram of the solution. How are we going to get the volume? If you remember, we have the specific gravity right here. The specific gravity is equal to 1.139. So, we can convert it into volume, no? So, we have 100 times 1 liter of the solution over 1.139 kilogram of solution. Okay, therefore, our V1 is equal to 100 divided by 1.139. It's equal to 87.8 liter. Okay. So, we need now to get V2, which is for 60% solution. So, we know the weight of M2 is equal to 44.4 kilograms. So, we have 44.4 kilogram of solution. And then, given din ang ating specific gravity, which is equal to 1.498. Okay, so we can convert this also into volume. So, we will multiply this to 1 liter of the solution over 1.498 kilogram solution. Okay? So, our V2 is equal to 29.64 liters. Okay? So, our requirement is to get the ratio of V1 over V2. This is equal to 87.80 liters over 29.64 liters. So, this is equal to 2.96, okay, liter of 20% solution over the liter of 60% solution. Okay, so now we got our answer for question number 2. Okay, so now we will go for the third question. Okay, our problem C. And in here, binigyan tayo dito ng ng scenario. So, sabi sa atin, what feed rate of 60% solution? So, itong hinahanap natin value, yung M2, no? So, what is the value of M2? Nagbago kasi ang ating condition dahil our product will be 1,250 kilogram. Okay, so meron tayong dalawang condition. If our product is 1,250, so what is our M2? So we have to remember this one thing, okay? On the first scenario na sinolve natin, yung M3 natin is equal to 144.4 kilogram. Okay? And in order to produce that, we will need 44.4 kilogram of 60% H2SO4 solution. Okay, so in our M3, okay, in order to produce 144.4 kilogram ng product natin, we will be needing 44.4 kilogram of our M2, which is our 60% solution, no? So, I will take note of this because ito yung gagamitin natin, no? So, I will take note of this. Okay? So, you can just write it down dahil we will go down. Okay? So, now, what we are required is to produce 1,250 kilogram of the product. Okay? So, yan ang ating requirement. And this should be per hour. Okay, so now we need to find out how many feed of 60% solution we have to use. So kanina pinatake note ko yung ratio natin, ano? So now we will use that in here. In order to produce 144.4 kilogram of product, we need 44.4 kilogram of our M2, correct? So now we could find out how many kilograms of M2 that we will be using, okay, in order to produce 1,250 kilogram. But we need to show it in terms of liter per hour. So we need to convert our volume of this solution into a weight of the solution. So we will use again yung specific gravity na ginamit natin dito, no? The specific gravity of our 60% solution is 1.498 kilogram per liter of solution. So we will use that here. 1.498 kilogram of solution per 1 liter of solution. Okay, so now we will get our answer because our weight of the product will be cancelled out. Okay. The weight of M2 will be cancelled out. So we have now liter per hour, no? Yan ang ating units here. So 1,250 times 44.4 divided by 144.4 and then again divided by 1.498 will be equal to 256.6 liters per hour. Okay, this is of 60% H2SO4 solution. Okay, and this is our final answer for this question. Well, that's it for now, guys, and thank you for watching. We are inviting you to register sa www.engineers.org. It is a community of Filipino engineers, engineering students, and STEM students. Thank you very much and have a nice day.